Good afternoon, or good evening, or good morning, or whatever it is there where you're watching. We are working today on volume. So we're going to start with the volume of prism-like objects, okay? And to be a prism or a cylinder-like object, we are going to think about these objects as objects that are sliceable. If we have an object that could be drawn as many slices, like this is a slice, and the top is a slice, and the bottom is a slice, then if I put those slices and stack them up this tall, h, then the volume of a prism-like shape, the volume, is equal to the area of one slice, or we'll just call it the base, because the top one is a base, and that's a base, and it looks like the same slice is going to be stacked all over the place. So the area of one base times however many slices tall this is going to be. So this was like a stack of cheese. You would have, the size of one slice times however many slices tall you're going to stack it. So that's going to be times h, the height of the stack. All right, so now we just need to go through here, and this is going to be a really easy packet. We just need to find the area of the bottom and multiply that by the height. So let's start with the area of the circle. Okay, we know that the area of a circle, the formula is going to be pi r squared, as long as we know what r is, and here they gave us a nice 8-kilometer circle. Dear God, what are these people thinking? A circle with a radius of 8 kilometers? That's a really big cylinder. But we can still work with it. That's pi times 8 kilometers squared. So the area of the circle is going to be 64 pi kilometers squared. And no, Caleb, you cannot put that as a decimal yet. Wait till the end. All right, so if I'm going to look at the volume, I also need to know the height. And this h, this number of slices thick, well, they gave us that as well. They call that 7 kilometers. So the volume will be equal to the area of that base times the height. So that is 64 pi kilometers squared times the height. And the height is going to be 7 kilometers. Now observe the units, guys. I'm going to move this up a little bit so we've got room to see here. Keep in mind what's happening with your units. It's always important to do unit analysis. So if I look, I've got kilometers squared times kilometers, and that's going to end up giving me kilometers cubed, because there's 3 of them there. All right, so the 64 pi and the 7, you normally can't add numbers like pi's with numbers that don't have pi's, but you can always multiply them. So 7 times 64, well, 7 times 60 is going to be 420. 7 times 4 is 28. So that's going to be 448 pi kilometers cubed. All right. And that is the volume of this cylinder. Is there a formula for this? Sure there is. Most of these will have formulas. I mean, honestly, this is a formula, and it's the easiest formula. Find the area of the base, multiply by the height. That works for all prism-like objects. So, but the area for the volume of a cylinder, if you want to memorize the formula, well, what's the area of the base? Well, we just said it. It's pi r squared. So they're going to say pi r squared times the height. So it's times h. That's your volume of the cylinder formula. Did you need to memorize this? No, not whenever it says area of a base times height. You can figure it out for yourself, and you don't have to take the time to flip open the book. It didn't take us any longer. You're still going to have to plug in all the numbers. You're still going to have to work it out and get 448 pi kilometers cubed. At this point, you could round if you like, but I want to see that you get to 448 pi. Okay, so let's take a look at one of these a little more difficult ones. How about number 2? That is going to be a hexagonal prism. So we said that volume is equal to the area of the base times the height. So first thing we need to try to find is the area of the base. Well, the area of the base, this is a hexagon. So we got to go back to what is the area of a hexagon? Let's see, that's the area of a hexagon. And that was 1/2 times perimeter times apothem. Okay. Oh, sorry, I'm off the screen a little bit here. 1/2 perimeter times apothem. And that's the new one we've been using. And the perimeter of this, since this is a regular object, they said this is 4 feet. Well, this is regular, which means these are all congruent. So that's 4, 4, 4, 4, and 4. So the area of the hexagon, a perimeter, is going to be 6 times 4. That's 24, because each one of these is 4 foot, and there's 6 of them. Times the apothem. Well, the apothem is this fancy little guy down here. He looks like a radius of the hexagon. So that's going to be times 3.5 feet. And don't forget that we had 6 times 4 feet here. So when we're doing our unit analysis. So this is going to be 1/2 of 6, which is 12, or 3 times 4 is 12, times 3.5. Well, 12 times 3 is 36. 1/2 of 12 is 6, so I believe this is going to be 42, and feet times feet is going to be feet squared. That's the area of the hexagon. Now remember, the volume is the area of that one slice, and then we're going to stack it however many slices tall. So the volume is equal to the area of the base times the height. So that means I'm going to do 42 feet squared. And how tall am I stacking it? Well, that's what this measurement is here. This measurement is 3 foot, saying that's how tall this side is. So I'm going to multiply that by 3 feet. All right. So if I multiply those together, I'm going to get to the volume. 3 times 40 is 120. 3 times 2 is 6. So I'm going to guess this is 126 cubic feet. There we go. And we are done. That's the volume. I'm telling you, this is so simple. Is there a formula for the area of the prism? Yeah, some books probably have something. I mean, basically, you could just do 1/2 perimeter times apothem times h. But I just don't think that there's any reason to memorize these formulas when area of the base times height is such an easy concept. And this area of the base times height could work even if the shape was a weird shape. I mean, what if it was something like this? I know what you're saying. Mr. Conaway, why can't you draw it in class? You always make a mistake on the board. All right, so if I'm going to do a shape like this, I could do this same shape. All I got to do is find the area of one slice and multiply by however many slices thick that is. That's the h. Okay, so this is the power of using this formula, area of the base times height, is you just have to find the area of one slice and then multiply it by however many slices thick it is. All right, so the same thing here with 3. Sure, is there a formula for this? Yeah, there is. And there's 3 different ways you could look at this. I could slice it this way. I could say, hey, look, guys, there's a slice, okay? And I could say stack them that way. I could slice it 3 different directions and look at how to add those together. It's not really that important which way you do it, as long as you do it correctly from one of the directions. So first of all, let's do the area of the base. I'm going to look at it this way and say this is the base. So that's going to be a rectangle with 7 on one side and 5 on the other. So that's going to be area of the base is 5 times 7. So that's going to be 35. Centimeters times centimeters is centimeters squared. So the volume of this is going to be that area of the base, so 35 centimeters squared, times the height, 6 centimeters. And multiplying this out, I'm going to get, let's see, 6 times 30 is 180. 6 times 5 is 30. So that's 210. And then centimeters will be cubed now that you do those together. Is there a formula for this one? Sure there is. It's called volume equals length times width times height, or length times width times depth, or length times depth times height, whatever you want to name them. Basically, you just multiply the 3 together, 5 times 7 times 6, and we did that, 5 times 7, and then we multiplied it by 6. And that gives us our volume. That's not a bad one to memorize. I use this one quite a bit just for memory, and I'll just look at this and say, oh, that's 6 times 5 times 7, and be done with it. Number 4. Well, we already did a hexagon, so let's move on and do something a little bit more challenging. So number 5 here is a prism, and it's got a base that looks like a triangle. More than that, it's a right triangle. And some of you might ask me, Mr. Conaway, how do you know which one the base is? Why wasn't the 3 by 3 square at the top the base? And why isn't this a pyramid? Well, when we look at a prism type shape, the base has congruent slices. So if I had a block of cheese and I gave you this block of cheese and asked you to slice it in such a way that every person got the same shape and size slice, well, the only way to do it would be to slice along this side here or the back side. So I could take and make slices this direction like this. Okay. That's the only way that I could make those slices work so that they would all be congruent. So now we want to say, look, what is the area of this red base, and then how high is it? Because volume equals the area of the base times the height. So that's going to be equal to the area of one base, is, well, the base here, and you might pause this and take a look at it yourself and see if you can find out the area of this base. All right, so the area of this triangle is equal to base times height divided by 2. Now, this is a different base. This is the base of the triangle. So when I look at this triangle, here's what I've got. I've got this triangle. And so this is 3, this is 4, and this is 5. So which one's the base and which one's the height? Well, it's really argumentative. I don't care what you call them, but they need to be 90 degrees from each other. And the 3 and the 4 are 90 degrees from each other. So I can call 3 the base and 4 the height. Or if I could turn it over and call 4 the base and 3 the height. It doesn't really matter what you call it. But it does need to be 90 degrees apart. And so 3 times 4 are 90 degrees apart. Multiplying that out, I'm going to get that is 12 divided by 2. And these are feet, so it's going to be feet squared, which is 6 square feet. So the area of one slice is 6 square feet. But I'm going to stack those slices 3 feet tall. So the volume is equal to that 6 square feet times 3 feet tall. Is there a formula for this? I don't know. Maybe there is. You could make one up, once again. Base times height divided by 2 times h. But this is, you got to remember, 2 different heights. Okay? This height is the height of stacking. Height of slices. Or the height of the shape. Whereas this h is the height of the triangle. So it's important to notice that we use 2 different h's here. One to represent this height of the triangle, 4 here, and one to represent the height of this whole shape, 3 feet. Okay, I'm going to skip number 6 because it is a cylinder and there is a formula for it. We already did it on number 1, so go back and look at number 1 and then come back and work number 6. All right, and I will be back with you guys for page 2.